I'm Max Clark. This is 20 Minutes Max. I've been on an SD-WAN kick lately with a lot of projects. So I'm recording a lot of SD-WAN content. Let's do a dive into SD-WAN and let's talk about SD-WAN. So let's back up and go way back in time. And 10 years ago, let's just go back 10 years. Let's just go to like late 2000s. It's a little more than 10 years. I guess let's go 15 years. Late 2000s, bandwidth was still very expensive and relatively slow, right? So late 2000s, if you had a 100 meg network circuit in your office, 100 meg internet circuit, you had a smoking fast internet circuit. If you had a gig circuit, oh my goodness, light speed. Now, big issue with corporate networking a lot of times is consumption of the network and what is using bandwidth and how do you control what uses bandwidth. When your applications and your infrastructure is on premise, 15 years ago, that was you still had a giggy network in, your office, and maybe you had some servers on 10 gig connections, but you had your office was all giggy to the server and it was low latency because it was in your office. As things started shifting off-prem, as we started implementing, hosted PBXs, and then, what became unified communications as a service, this UCaaS product, right? So, think of what RingCentral 8x8, Vonage, Zoom, anything that's Microsoft Teams related infrastructure, Dialpad. I'm missing a bunch. Sorry if I didn't call you up by name. It's morning here. And as your servers went off-prem, and whether that was just like Dropbox or Box, or you went to SharePoint and OneDrive, or you did Google Drive, or, whatever it is, applications went into, AWS or Azure or whatever it is you're using. All of a sudden, that fancy giggy circuit, that giggy network, your desktop to your servers, became the fastest thing, and your construction became your internet circuit. And now the performance and the speed of that internet circuit became really critical. But maybe it was only a 100 meg circuit. And maybe you had events where, you had Windows Update running, and Microsoft does a really good job of making these updates go and use as much bandwidth as humanly possible and suck up all the application. Or maybe you didn't have any sort of filtering or restriction on your office, network connection, and, Netflix or YouTube became an issue for you. Or, maybe you're doing large file transfers, you're using Aspera because you're a media entertainment company, you're doing big transfers. Well, now you have applications that are latency sensitive or jitter sensitive or packet loss sensitive or just network sensitive running. Okay, so your voice applications, your video applications, things along these lines. 15 years ago, it's actually a little bit more than 15 years ago. So I'm just going to say 15 years ago. 15 years ago, if you were a service provider in the voice world, you were solving this problem, and we had the Edgewater Edge marks came out. This is, in my mind, really one of the big precursors to what we see in the SD-WAN market space today. EdgeMark was a magic device, and they branded it as, an Edge SBC. It did a lot of different things. You could terminate, voice traffic to it. But the big thing that it really did was it sat in between the firewall and the ISP connection. And it was there for a very important reason. And that reason was it could issue TCP resets. Now, what the heck am I talking about? When you think about your network connection and you're thinking about your internet circuit, like your pathway to the internet. So here's the internet and here's you over here. And you've got this pipe in between you. When you start downloading stuff from the internet, how much you can get and how fast you can get it is this pipe. And the best analogy I can think of offhand is like trying to suck a milkshake through a straw. You can only get so much data through. And as soon as you clog up this side, like if you, like me, and you like Oreos in your milkshakes, chunk of Oreo hits the end of that straw, it plugs the straw, and there's nothing you can do on this side, on the office side, to deal with it. You've already saturated your capacity in your network circuit. And there was no way to deal with this, right? So if you were, you could subscribe to a really fancy service with the LEC, and you could get into QoS traffic shaping with that LEC. And this was usually done on MPLS circuits. As part of the reason why MPLS circuits were so much better for people for so long was because the telco could actually set the QoS rules and provide priority to different things, provide a priority to your video and to your voice applications and your critical application, and then have like this generic data layer underneath of it that, could use whatever was left over. But in order for QoS to work properly, you have to have it on both sides. Both sides need to know what's going on. Far into that straw needs to know your circuit's 100 meg and the circuit's saturated. So prioritize your voice traffic and tell everything else tough, you get what you get. Tell our children, you get what you get and you don't throw a fit. So what EdgeMark did, because it was on this end of the straw, as traffic was coming into it, it obviously couldn't control what was happening over here, but what it could control was the rate at which traffic was accepted And it did this by, when it detected a saturation of the network, it would issue a TCP reset and it would slow down that transfer. Fun little quirk of TCP, it would see this as a packet loss, and it would start doing retransmits, and your window sizes would reset, and it would slow that transfer down, and the edge markets it could provide this like artificial rate limiting for you. And the behavior and what you saw or you experienced was you might have a period of like your voice would get a little wonky, and then this thing would kick in and it would, wreak havoc with everything else, but your voice traffic would improve, and, your overall experience was much better. And so if you were like us and you were doing any sort of hosted VoIP, hosted PBX, SIP trunking, PBR, PRI replacement, whatever it was, these were all, this was a phenomenal appliance to send out into the world because it solved a lot of issues for you before those issues popped up. Around that same time, what else was really popular? FatPipe. FatPipe was really popular. And FatPipe was, and still actually is, a way of doing circuit aggregation. So if you had a cable modem plus a DSL line plus a second cable modem plus something else, you could take and you could effectively slam all those together and aggregate all your bandwidth together and have better internet performance. And this is not like a new technique. I mean, we were doing this, the late 90s, early 2000s with modem bonding. Microsoft Proxy Server, 1.0, you could take and have a 4 US Robotics modems plugged into the back of a computer and have it. And the trick was we'd use like Earthlink. We'd use like Earthlink and get an ISDN account, because they couldn't tell you that you were dialing in multiple times, because that's what ISDN was. It was effectively a digital modem dial-in with two circuits at the same time. So they would remove any sort of rate limiting that would prevent you from dialing in more than once. So we'd take 4 modems back of server, get an ISDN account from Earthlink, and just dial in. And all of a sudden you went from it was just 56K to 128K to 256K. It was like smoking fast. I mean, late 90s, 256K of dial-up was like a rocket ship. And then DSL came out, and then we started transitioning. Of course, that was because T1s and frame relay were just so egregiously expensive still. And then they started getting cheaper, and then there was a wholesale migration to T1 and yada, yada, yada. When we look at SD-WAN now, the easiest way I can express what SD-WAN is it's multiple different buckets of things, right? So it is, a cloud-based orchestration and automation tool to do configuration. Right. So you could have a Meraki, and you're going to the Meraki cloud in order to configure your endpoint. So when you plug a switch into your network, it knows to phone home to Meraki and say, this is who I am. What should I do? And then Meraki will push that configuration down to the switch, and the switch will configure itself. And it's magic, right? Like if you've never consoled into a switch and had to configure it from scratch, then maintain its config, and then hopefully you didn't lose your config, if you weren't using something like Rancid, it's wonderful. Meraki's wonderful for this stuff. Point and click VPN between MX firewalls. Again, magic. If you've configured VPNs from hand on a CLI versus if you just go and click and turn the VPN on. So you've got configuration-based SD-WAN. You've got this internet optimization, right? So you've got this continuation of what this idea of the EdgeMark was, or FatPipe, where there's special SD-WAN service providers that give you an appliance with failover and the ability to aggregate, so bond multiple circuits together. And in most cases, we only really see people bonding, 2 circuits. We're using it for failover and survivability. So fiber circuit with cable circuit plus wireless circuit, fiber plus wireless. Just the big important thing is different carriers, different medium of access into the building, and also inbound, gateway, foreign gateway with inbound survivability of IP addresses. And there's some negatives with this version of SD-WAN. The big one is your MTU sizes. I mean, you're running VPNs inside of VPNs at some point. It may or may not be a problem for you, may or may not be an issue for your application. Wonderful, wonderful option for, SD-WAN. Talk a lot about like this MPLS replacement SD-WAN. If you're really looking at, your primary application is providing connectivity between branch locations and HQ or branch locations and data centers. So really this like hub and spoke kind of infrastructure, central locations with remote locations. Excellent options in the SD-WAN space. Is probably the most common SD-WAN we see in the market right now is serving that use case. These things have then been extended and augmented with techniques and approaches to deal with SaaS applications or hosted cloud hosted applications. So UCaaS of voice being the big one, and of course interactive video, so Teams and Zoom and whatnot being the other one. And my last bucket of SD-WAN that I talk about a lot is really more like latency and performance orientated, cross-continent, low speed links, high latency applications. If you've ever dealt with a gas station in the middle of nowhere on the 10 freeway in the United States that's got a old school satellite uplink that needs to have a point of sale terminal with some sort of ERP, in order to process credit cards to drive transactions, it's doing just boatloads of money, a day because that's the only gas station, and as far as the eye can see in each directions, well, there's not a lot of options in the middle of nowhere. The gas station's doing great business because it's the only option in the middle of nowhere. It also means that there's no network options in the middle of nowhere. SpaceX and Starlink is starting to make changes here, but it's still, you're dealing with applications that are not going to have the same amount of performance as you would in other scenarios. Evaluating SD-WAN, I've kind of given some generalized buckets here pretty quickly. The amazing thing about this is if you're in a selection and purchase process, we haven't even talked about SASE. I was ranting about that in another recording here recently. But if you know nothing about SD-WAN, you just think about it in those kind of groupings, you're going to know pretty quickly what problem that you're trying to solve. What is the issue that your business has? What is the issue that you actually have? And the sooner you actually appreciate or accept that, the easier it is for you to focus on it, right? Like why do an RFP with, a dozen vendors when 9 of those vendors don't actually do what you need them to do? Or they can claim that they do what they need you to do, but they actually don't do it, or they don't do it well, or it's not their core competency, right? So there's no point, right? This is the whole thing. RFPs are garbage in most cases because they're just spray and pray out to everybody. And guess what? You're not even actually evaluating whether or not that vendor is going to do what you need before you send them this document to say, do you do what I need you to do, right? Don't waste your time. Identify what it is that you want and what kind of network infrastructure and architecture that you actually want. Where are you today and where are you trying to go? What problem are you trying to solve? When you think about it in 3 years, do you want to still have on-premise firewalls? Do you not? How does your SD-WAN architecture actually apply into that? Are you going to maintain data centers? Are you not? What applications do you have? Are you going from an on-premise voice to, a hosted voice or to a UCaaS environment? How does that impact things? Are you going to maintain it on, do you have critical applications on site that are never going to leave site? All these things kind of swirl into this little pot, right? You stir the pot and you say, okay, great, this is what we need. That's all super critical. Word of warning, because this has come up a bunch. There's no SD-WAN on the market that solves the issue of data center and survivability. SD-WAN is a great just magic button to solve all your remote site edge issues. Pick your category of edge issues and solve it. But when you actually start talking about getting into a data center application of, I want to have QoS inbound on my transit links into my data center, just buy bigger transit links. If you're in a data center, it's easy to go get 10 gig links, right? Go get a bunch of them. But you're going to have to run BGP, or you're going to have a really solid network provider, a transit provider that can give you redundant circuits and provide that redundancy for you ingress and inbound. Now, there's trade-offs to running BGP and having different carriers and different ASs that you're connected with versus a single AS with a single carrier. And serious when I say I'm more than happy to nerd out about this all day long on a whiteboard. And, there's nothing I like more than, designing data center network applications, because that's just the way my brain works. And, everybody has their hobby, things they do for fun. That's what I do for fun. I'm just going to put it out there. Anyways, SD-WAN is magic, and it solves real problems. And if you're on the customer end, or if you're on the service provider end, you want SD-WAN in place. And if you're, crazy, if you're turning over IT staff, or if you're an executive that's just taken on, more responsibilities, or have slotted in and replaced an executive that has purview over infrastructure, and you're looking down your line items on your budget, and you see these things that are called SD-WAN, that thing is there to make your life better. And the reason why your life is good right now, and your IT team's life is good, is because it's there. Don't get rid of it. Big secret. I'm going to tell you, free information here. SD-WAN is good. Keep it. Don't get rid of it, because what happens is if you get rid of it, all these issues you didn't realize that were there because your SD-WAN is hiding it from you because it's doing its job. It's going to bubble up to the surface, and then all of a sudden you're going to have to start talking about why is our voice terrible? Why can't we get to our application? Why is our productivity down? Why did this location go down? Why are we having outages? Well, the outages came about because you got rid of this magic box, and that magic box is there for a reason. So keep it. So SD-WAN good, no SD-WAN bad. Pick the right SD-WAN. Don't waste time, circling around with people that can't do what you need them to do. I'm Max Clark, and that was 20 Minutes Max.